Welcome back. Let's just dive right in because today we are exploring an absolute game changer for your development stack, OpenAI's Assistance API and real-time capabilities. We're literally looking at the exact architecture that takes those simple one-and-done text generators and evolves them into fully autonomous, tool-wielding cyber agents. So if you've been grinding away relying on the standard endpoints, well, get ready, because this is where we level up.
Let's actually kick things off with a question that hits right at the biggest pain point we developers face right now. What if your AI just never forgot? I mean, imagine building a cyber agent that remembers literally everything without you having to constantly write clunky code just to feed it the exact same context window over and over again. We are talking about a system that seamlessly holds on to state, context, and history across every single interaction. It instantly eliminates one of the biggest bottlenecks in AI app development today.
Okay, here's our initialization sequence for this explainer. First, we'll cover the stateful AI evolution. Then, we'll break down the core primitives of assistance, look at equipping advanced AI tools, explore the streaming and real-time API, and finally wrap up with building your cyber agent. Right, let's jump into part 1, the stateful AI evolution, upgrading from amnesic to autonomous. You can really see the core architectural shift here. Looking at the traditional chat completions API, it's inherently stateless. You have to manually manage everything, the conversation state, defining your tools on every single call, passing in retrieval documents, executing the code yourself. You're basically babysitting an amnesic assistant who completely forgets who you are the second you stop talking. But then, looking at the Assistance API, it's a completely stateful evolution. It automatically encapsulates your models, your instructions, and your tools inside a persistent environment. This is huge because it radically simplifies your code since the API is handling all that heavy memory management for you. Moving on to part 2, core primitives of assistance, the holographic architecture. So first up, we need to define the assistant itself. You can kind of think of this as the primary configuration file for your agent's personality and its boundaries. It's the base entity that holds your specific model choice, like GPT-4o for example, along with your custom instructions, access to specific tools, and any context documents you might have uploaded to its memory banks. Basically, it sets the baseline rules of engagement for how your agent is going to behave.
Next up, we have threads. Think of these as the secure, glowing fiber optic lines that permanently store the state of your ongoing conversations. They hold the entire message history. And you know, the big why this matters for us as developers? It saves you a massive amount of money and time. Because threads are persistent, you completely bypass the token cost of sending the entire conversation history back and forth on every single request. The thread just remembers.
And finally, we have runs. These are the active execution engines of the whole system. When you actually trigger a run, you're commanding the assistant to execute its logic on a specific thread. It autonomously chews through the data matrix, triggers textual responses, and processes complex multi-step actions. It looks at the history, decides exactly what needs to happen next, and then just executes. Oh, and just a quick technical checkpoint for your local terminal. To power all these primitives properly and reliably, you need to ensure your Python SDK is updated to at least version 1.59.4. That's a super critical step to unlocking full Assistance API support in your environment, without slamming into annoying deprecation errors. Okay, part 3, equipping advanced AI tools, wielding cybernetic capabilities. Let's switch our command center lighting to a deep tech magenta for this one. Because your upgraded agent, it isn't just a basic text generator anymore. You can now interact with the outside world using this incredible arsenal of tools. Looking at the latest documentation, you can equip it with everything from precise function calling to query your private databases, to natively analyzing a massive spreadsheet with Code Interpreter, all the way down to direct computer use and local shell access. You're literally giving the AI's brain a set of hands to do the actual work. But we really need to clarify how this actually works in practice, because the AI doesn't directly perform the action, your application does. When we use function calling, we enter this really strict 3-step execution loop. Step 1, the model realizes it needs external data and outputs a tool call with specific arguments, like say asking for the weather in Paris. Step 2, your application catches that request and securely executes the weather function locally. And then step 3, your application grabs that fresh data and feeds it right back into the model's stream, which allows the AI to formulate its final answer. The absolutely crucial point of that whole loop is summarized perfectly in this quote from the docs. When you feed that data back during step 3, Your application's response must strictly map back to the model's original call ID. If you don't explicitly reference that exact specific ID, the whole data stream breaks. The agent basically loses its train of thought because it has absolutely no idea which question your data is supposed to be answering. To keep your cyber agent from glitching out during these loops, you definitely want to enable strict mode for your JSON schemas. What this does is guarantee that the JSON your agent spits out will perfectly match your exact specifications every single time. It literally eliminates application crashes caused by the AI hallucinating some weird, faulty data structure. Now, the documentation does mention that the very first uncached request might experience a slight latency bump as the schema processes, but honestly, that reliability trade-off is absolutely worth it. Moving right along to part 4, Streaming and Real-Time API, Low Latency Sensory Inputs. This breakdown shows exactly how you connect to the real-time API. You basically have 3 primary transport protocols depending on your architecture. WebRTC is your go-to for browser-based voice and audio. WebSockets are there to handle multimodal, text, audio, and function calling. And then there's SIP, which actually bridges your agent directly into telephony systems. That last one is a massive deal if you're trying to build automated, highly responsive customer service phone lines that sound completely indistinguishable from a human. If we peek under the hood at the Python SDK, you'll see it relies heavily on WebSockets. This maintains a live, continuous stream of client and server events. So instead of those traditional REST APIs where you're just sitting there waiting for a massive chunk of data to process and return all at once, your system achieves this ultra-low latency. It's fully bidirectional. That means the user and the AI can actually talk over each other in real time, instantly adapting to interruptions, just like you would in a natural, everyday conversation. The real power of this streaming capability, though, is visibility. Because the data flows in continuously, you don't have to leave your users staring at some spinning loading wheel. You can actually watch your agent's thought process as it fills out function arguments, character by character, and surface that progress directly in your UI. It creates an incredibly engaging experience because users get this mesmerizing real-time view right into the machine's underlying logic. And finally, part 5, Building Your Cyber Agent System Upgrade Complete. So, you now have the full picture of the architecture. With persistent memory through threads saving you those massive context costs, custom external tools granting your agent the hands it needs to interact with databases, and ultra-low latency bidirectional streaming completely at your fingertips, the foundation is fully laid. The only question left to answer now is, what kind of autonomous cyber agent are you going to build? Thanks for plugging into this explainer, keep building, keep experimenting, and we'll see you in the next upgrade.